Hello students. So for question number 2, they have given us 6 digits which are 4, 5, 6 and 3, 7. In how many ways they can be arranged? So the keyword is arrangement again. So we'll be using the permutation part. So that the 6-digit numbers are formed and how many different 6-digit numbers can be made. Now the thing is they have asked how many different 6-digit numbers can be made. So 6 of these digits can be arranged in 6 factorial ways. Now out of which we have 3 sevens. See students, what happens if this is my 7 number 1, if this is my 7 number 2, and if this is my 7 number 3. So if I'm even arranging say 7 number 3 here first, writing 2 here and 1 here. So the value of the number does not change because all these 3 sevens are identical. So by the total number of arrangements, we divide by the number of elements which are identical. So there are 3 sevens which are identical. So it is divided by 3 factorial. So the answer for the first part is 120 ways 6 different 6-digit numbers can be formed. Now, if I'm going for the part 2 of the question, it says that how many of these 6-digit numbers start with an odd digit and end with an odd digit. So suppose 5 is an odd digit starting with 5 and ending with 7. So 2 of the digits of the given 6 digits I've already placed here. So the 4 remaining digits can be arranged here in 4 factorial ways. Now out of which again 2 7 will be identical because 1 7 I've already placed here. So 2 7 will be identical. So the entire permutation will be divided by 2 factorial, which is 12 ways. Similarly, if I place 7 over here and I have still a 6-digit number to be formed, so it should end with 5 because it should end with an odd digit. So again, the 4 places can be filled up in 4 factorial ways, and again since 2 7 is repeated, so it will be divided by 2 factorial. So I still have 12 ways of doing this. Now in the third part, once 2 7s are fixed over here, so the 4 places can be filled up in 4 factorial ways, but then we are left out with 1 4, 1 5, 1 6 and 1 7 since 2 7s are placed over here. So none of them is an identical or a repetitive digit. So it remains 4 factorial over here. So which is 24. So either this can be the arrangement or this can be the arrangement or this can be the arrangement. The keyword is all. That means we have to add all of these. So if we add all of these, we get 48, which is an answer for the second part of the question. Thank you, students.